Now, what about permutations with non-distinct items? I mean, when you have a prize where one is different than the other, I mean, it's pretty obvious. It's like the one we did above. Or even when you have, for example, the kids lining up and stuff like that. It's you know, somebody's first, somebody's second, and so on, right? But what if the kids were indistinct from each other? What if the prizes, not the prizes, but the winners, what if Dale and Evan, I don't know, were identical twins or something? Then how would that work? That's what this solves for us. How many different words can be spelled from arranging the letters in Tom Marvolo riddle? Okay, so we want to make a permutation. First of all, there is an order to words. That's kind of the reason why homonyms are not the same thing, right? Or I think it's homonyms. Oh, I can't remember now what the name for them. Oh, it's not homonyms. Shoot. Oh, I can't remember the name. But it's the ones where, hold on, let me think of one. There we go. Matt and Tam. They use the same letters, but they don't mean the same thing at all. Matt is obviously, you know, mat on the floor, and Tam is something you wear on your head. It's a name for a type of hat. Okay, so we want to know how many different words I can make. And in words, of course, there's an order to them. We start at the left and move to the right in English. So let's look here. I have how many different letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different letters. All right, so I already know it's going to be 16 factorial in the numerator. Oopsie. There we go. But then they want me to figure out all the different types of kinds there are. All right, well, that's going to be, now let's think. I have 1 T, 2 O's, or 3 O's. You know what, I'm going to make a table of this just to simplify our lives. Hold on one second. Actually, it occurs to me the way I'm going to do this is going to be kind of crafty, so you might want to know what I'm doing. So let me type all these letters. T, O, M, A, oops, R. All right, hold on. I'll pause and I'll be right back. Okay, there they are, typed in. And I'm going to make Excel order them for me. The way you do that, let me just show you. You click on the Data tab, and you click Sort, and it'll put them in order. Nice, huh? Okay, so we can see we have 1 A, 2 D's, 1 E, 1 I, 2 L's, 2 M's, 3 O's, 2 R's, and so on. Now, what really matters to us here is the repeaters. The ones that don't repeat, they're just 1 factorial. So it's going to be 1 factorial for this one, 2 factorial for those ones, because there's 2 of them, 1 factorial for this one. These are going to go in the denominator. 1 factorial for this one, 2 factorial for that one. Right, the 2 L's, 2 factorial for that one, the 2 M's, 3 factorial for the 3 O's, 2 factorial for the 2 R's, 1 factorial, 1 factorial. All right, so all of that gets put into our lovely denominator. So we say, okay, I want you to take that and divide it by 1 factorial times 2 factorial times 1 factorial, 1 factorial, 2 factorial, 2 factorial, 3 factorial, 2 factorial, 1 factorial, 1 factorial. All right, well, most of them don't matter to us because the 1 factorials are just ones, right? Because 1 times itself is 1. So all we really care about is 2 factorial, 3 factorial, 2, and 2, and 2. So I'm going to make Excel find for me, first of all, what factorial of, oops, I'm in cap locks there, 16 is. Really big, right? Really huge. All right, then let's find factorial for 2. And factorial for 3. Just, oops, I typed that wrong. 3. All right, 2 and 6. Okay, so if I have 1, 2, 3, 4 2's, so that's 4 times 2, right, times another 6. That's 48, and then I want to take this number and divide it by 48. Oopsie, divide by that number. And there we go. So it's equal to 2.09228 E13, right, scientific notation, over 48, which leaves me with 4.3589 E11. Lots and lots and lots of different ways to write those out into words. All right, cool. We're done with that section. I'll move on to the next bit in a bit.